In continuation with our previous video, here we will see some of the terms which are used in the governors. Okay. So first, sensitiveness of governors. So what do we mean by sensitiveness? So suppose if we take the example of any governors for comparison, when can we say that this governor is, example, governor A and governor B? When can we say that governor A is more sensitive or else governor B is more sensitive when compared to the other? So when do we say that it is sensitive? See, whenever there is a small change in the speed, what happens? The sleeve will lift up or down depending upon the increase or decrease in the speed. So in comparison with two governors, which governor, governor A and governor B, if governor A fluctuates more when comparison with governor B, then we call it as the governor A is more sensitive than governor B. This sensitiveness depends upon the sleeve movement up or down with respect to the change in speed. The governor which fluctuates more up and down is said to be more sensitive. So you can see here, consider two governors A and B running at same speed. We will be assuming that they are both running at same speed. When this speed increases or decreases by a certain amount, the lift of sleeve of governor A is greater than the lift of sleeve of governor B. Then it is said that the governor A is more sensitive than governor B. So this is what I explained till now. So how can we write the sensitiveness in the form of an equation? Okay, so what is sensitiveness? It is defined as a ratio of difference between the maximum and minimum equilibrium speed to the mean equilibrium speed. So we have seen in the derivation part. How do we denote maximum speed and minimum speed? N2 is the maximum speed, N1 is the minimum speed. What is the mean speed? It is N. So how do I represent this? So N1 is the minimum equilibrium speed, N2 maximum equilibrium speed, and mean equilibrium speed. It is what? N1 plus N2 by 2. This we know. Mean. It is the average of the maximum and minimum. So how can we write the equation for sensitiveness of the governor? Sensitiveness of the governors, as I have told, difference between the maximum and minimum equilibrium speed. N2 is the maximum equilibrium speed, N1 is the minimum equilibrium speed, N is the mean equilibrium speed. Difference between the maximum and minimum to the mean, that is N2 minus N1 by N. So what is N? N1 plus N2 by 2. What happens if I substitute this here? It becomes 2 into N2 minus N1 divided by N1 plus N2. So if I write N2 and N1 in terms of omega, angular speed, it can be written as 2 into omega 2 minus omega 1 divided by omega 1 plus omega 2. N1 and N2 in terms of RPM, omega 1 and omega 2, it is in terms of angular speed. So this is how we denote the next hunting. So what do you mean by hunting? A governor is said to be hunt if the speed of the engine fluctuates continuously above and below the mean speed. When it is said to be hunt, when the engine fluctuates continuously above and below the mean speed. So there is some mean speed for each and every governor. If the governor is continuously fluctuating between the above and below the mean speed, it is called as what? It is called hunting. Why is sensitiveness caused? Because it is because of a too sensitive governor. So in previous slide we learnt about the sensitiveness of governor. What is sensitiveness? It is the lift of the sleeve for a small change in the speed. So hunting is caused when the governor is too much sensitiveness, which changes the fuel supply by a large amount when a small change in the speed of rotation takes place. So whenever there is a small change in the speed, what happens? The governor fluctuates continuously above and below the mean speed, and this makes the governor too sensitive, and there will be change in the fuel supply. So this governor which fluctuates above and below the mean speed is called as what? Is called as hunting of a governor. Now, stability of a governor. When can we say? When can we say that a governor is stable? When can we say? If I take example of general example, when can we say something is stable or some person is stable? If we don't change for anything. So, taking example of a governor, how can we define stability? A governor is to be stable when for every speed within the working range there is a definite configuration. That is, there is only one radius of rotation of the governor balls at which the governor is in equilibrium. For a stable governor, if the equilibrium speed increases, the radius of governor balls must also increase. So stability means that the governor is stable. For a particular speed, there is a particular radius of rotation. It is stable. It won't continuously change depending on if there is a change in speed. It won't continuously change. It is stable. That is, there is a definite configuration for it. The configuration for it. This governor for this radius of rotation, this is the speed and this is the lift. For each and every thing, there is a valid value. Next, what do you mean by isochronous governor? A governor is said to be isochronous when the equilibrium speed is constant. That is, range of speed is 0 for all radius of rotation. So we can say that when the governor is said to be isochronous when the equilibrium speed is constant. Equilibrium speed, it is in the shape of L shape. That is, as I told. So equilibrium condition, there is no change. All the radii of rotation of the balls within the working range, neglecting the friction, everything will be in a stable condition. The isochronism is a stage of infinite sensitivity. Next, what do you mean effort and the power of a governor? So this effort and power, these are the two terms which are linked with each other continuously. So what do we need when we say that we are putting more effort? When we need a more output. So here input is the effort and power is the output. So whatever we express here in terms of input and output, effort is the input and power is the output. See, the effort of a governor. First we will be learning about effort. What is effort? The effort of a governor. So here effort means what? We are talking in terms of governor. Why should we put effort here? Because the sleeve has to lift. Sleeve has to lift up and the sleeve has to go down. So for a particular lift, we have to put some particular effort so the sleeve will go up. The effort of a governor is the mean force exerted at the sleeve for a given percentage change of speed or lift of sleeve, as it will lift of sleeve. It may be noted that when the governor is running steadily, there is no force at the sleeve. But when the speed changes, there is a resistance at the sleeve which opposes its motion. It is assumed that this resistance, which is equal to the effort, varies uniformly from a maximum value to 0, which the governor moves into its new position of equilibrium. So to change its position, to change to its new equilibrium position, you have to put some effort. So the effort is put at the governor sleeve so that it increases or it will be moving at for a particular point to form a new position of equilibrium. So now what is power? Power is the output. See, the power of a governor is the work done at sleeve for a given percentage change of sleeve. It is the product of mean value of effort and the distance through which sleeve travels. So as I told, power is the output. Output, how it is measured? It is measured in terms of this effort. Where we are putting effort, we are putting at the sleeve. So the sleeve has to move up. So power means what? Effort, the product of effort and the lift of the sleeve. So you can see it once again. The power of the governor is the work done at the sleeve for a given percentage change of speed. It is a product of mean value of effort and the distance through which the sleeve moves. Mathematically, how can we write it? Power is equal to mean effort into lift of the sleeve. Effort and the lift of the sleeve.